My screen is visible, right?
Yes, it's visible.
Okay, hi everyone. Let's wait 2-3 minutes more so that everyone will join. Then we can get started.
Meanwhile, shall I launch the poll or shall I wait for people to join in?
I think we can wait 1 more minute, then you can go ahead.
Okay.
Yeah, I think we can get started. It's 5-2. So first of all, hi everyone. Good evening. Welcome to our Geek Night. So we appreciate you for joining us today with the Geek Night. Sorry, yeah. So first of all, if we talk about GeekNight, it's a platform where geeks comes together to learn, discuss, and share technologies. This is what ThoughtWorks believe, and this is fully organized and sponsored by ThoughtWorks. So first of all, once again, very welcome to everyone. Before we start, let's quickly talk about the agenda. So we have one interesting session today, which is Basics of Machine Learning and Neural Network by Meeraj. It's about the basic background of ML and the foundation for the neural network. And as we have only one session today, so we will take a quick break of 5 minutes to grab a cup of coffee or tea. Then after that, we will continue from there. So this is the agenda for today. And before we get started, let's talk about some ground rules. That one is raise hand. This is, as you may know, that in Zoom there is a button in bottom corner that raise hand. So if you have any doubts or any queries, or if you want to talk to our speakers, please feel free to raise your hand so that we will allow you to talk to our speakers and you can interact with them. And next part is Q&A session. In case if you have any queries or anything to share, please post it in the Q&A session. Try to answer the questions. And third one is survey. We know Yeah, I'm so sorry. There was an internet issue. Let me share the screen again. Yeah, it's raining here, so just give a second. Am I audible now?
Yes, Kirti, you're audible. Probably you can go off video.
Yeah.
Mhm.
Yeah. So I was talking. Sorry for the delay. I was talking about ground rules. So we have ground rules so that we can make this session more interactive and effective. So the first one is raise hand. It's in the bottom corner, and you can use that raise hand option to raise hand option if you have any questions or if you want to talk to our speakers. Please use it. And we have Q&A session. If you have any queries, please post it in the Q&A session so that we will be able to take it up and try to answer. And the last one is survey. As we know that most of us maybe know that ThoughtWorks gives uh, importance to feedback. So if you have any feedbacks, please feel free to share with us. Yeah. So without much delay, let's go to the session directly. Over to you, Meeraj. Let me stop sharing. Yeah.
So before we start, I just want to have a pre-poll. I'll just give 2 minutes to answer certain questions. So I'll be launching untitled poll now. I just give 2 minutes. Yeah. So I think most of the people have given their polls. So how can so I think like most of the people are new to machine learning, and there is a nice distribution between Java and Python for this one. And then yeah, many of you are interested in machine learning, and yes, I think most of them here are like beginners. So yeah, this session is good for the beginners because I'm trying to focus what is basics of machine learning. So 3 years back, I was very enthusiastic like you to to learn something about machine learning and to do application in machine learning. But thing is that I was fascinated by the vast number of machine learning applications like image recognition, voice translation, and lot many things. But after joining those 3 years of course, that what I found out is that I'm missing the basics about it and have wasted a lot of money. So if you are planning to start machine learning course, well, probably I can give you a kickstart for you, because there are a few things have been assumed whenever you enter into course, because all those courses are taught in master's degree. So in master's degrees, all those students will be proficient in matrices and some of the graphs concept and all those things, which most of us may not be well versed with it. So that's the reason why I started giving my contribution to ThoughtWorks, so that people can learn few things about it. So I will show you the things which I'm going to cover today. Okay, there are so many things. So this is the syllabus I'm going to present it today, just basics. So what is the expectations? So like what is the machine learning? So what are the tools? So I will be presenting one tool to showcase you how you can apply a concept with the help of the learning. And these are the different topics which I will be covering, like machine learning, mean, covariance, some of the things about eigenvalues and eigenvectors, so loss functions, gradients, and simple naive Bayes. And the second thing today I will be covering up linear programming and some of the linear integer function programming, some of the explanation at grassroots level. What you can do is I have uploaded some of my videos. You can simply go to YouTube and type my name, Neeraj Kanaparthi. So you can see my channel here. So here I have mentioned some of my learnings, basis of machine learning and some of the machine learning algorithms in three different languages, English, Hindi and Telugu. So in each subject you can go, and I have provided the source code. I have provided the source code, GitHub links, and some of the references, and you can see all those information in the blog also in written everything about it. So yeah, so I have 17 years of experience in IT industry, and I've mostly worked in Java JT projects. I had also worked in Python projects also. So I'm passionate towards the technology. So my intention to learn in machine learning is to create robots. Now that's very long way ahead. Right now I am not successful in IoT itself. So in future, let's see how it goes. So so before I show you these slide slows, I like to explain you some of the concepts in the board. So let me turn off this video and turn off the other device so that I can explain more in the board. So if you have any questions, please write in those questions and in chat. So one of our peers will be stopping me to explain if anything is missing or anything is not understandable. And this session is more about interactive, so take your own time and try to understand what I'm trying to teach today. Yeah. So guys, can you hear me? I have to stop sharing the screen. Okay, you can see my screen. Okay.
Yeah, Meeraj, go ahead.
Yeah. I think you can hear me, right? Are you able to hear me? Okay.
Yeah, I can hear.
Okay. So this is all about high school mathematics. So in our schools, we see that we have a graph x and y. So we have x-axis and we have x-axis, and we have certain points. So as a human, when you observe, so you can draw many points as you want. But as a human, you know that most of the points are in this line. But thing is this: how do you can make a machine to understand that? Is my voice echoing?
No, it's fine.
Okay. Okay, fine. So
Yeah, maybe you can put the mic little closer. Sorry, you can put the mic little closer. Yeah, go ahead.
Now is it better?
Yeah, better.
Okay, fine. So how do you teach a machine to understand that this is a particular model it needs to understand, so that we can make some predictions? Let's say you have a house in a particular area, so maybe like 1,000 square feet and maybe like 200 square feet, and you're selling it for like 1 lakh or 2 lakhs or something like this. And you want to make a prediction, like if it's 300 square feet, what should be the value about it? So this is kind of a prediction problem. How do you are able to do it? If you go for statistics, there is something called best fit algorithm. So what best fit algorithm is that it try to, whenever you have given a point, so it will analyze what should be the minimalistic error, so that you can define a line which has a particular slope and particular intercept. So that once you have these particular models, So you can give a prediction like for a given value, what should be the output. So this is all about. I think if you go into Andrew NG classes, you might have seen graphs something like this, and maybe in some of the machine learning classes, you might have seen graphs like this. So what are all these graphs? So this is nothing but what we are doing is we are trying to define a particular model, a particular set of coefficients where you can do certain predictions, and basically on predictions you want to display the output, and it has a wide spread of applications. And this is there since the beginning, 1970s and 1980s. This application is evolved over at a time. So far, so that if you understand the concept, you can implement in whatever languages you want. So, okay, this is about the best fit. Let me explain how the best fit algorithm works. So, let's say you have a particular graph and you have some points here and here and here. So this is like 1, 2, 3, 4. This is 1, 2, 3, and then let's say it is 4. So this is nothing but 1, 2, and this is nothing but 2, 1, and this is nothing but 3, 2, and this is nothing but coming around. Okay, this is sorry 2, 3, and this is let's say here 4, 4. So given these points, so what the best fit algorithm does is it will try to calculate. So it will look at the values of x and y. So what are the values of x and y? 1, 2, 1, 2, 2, 1, and 2, 3, and 4, 4. So what we'll do is we'll try to calculate the total. So 4 plus 2 plus 2 is 8, 9, and let's say 2 plus 1 plus 3, like 4 plus 4, this is 10. Okay, and this is 4. Let's assume that we'll try to figure out it 1 to be less. So it's, let's say this is 3. Let's say this is 3, 4. Then this total comes around 10. Okay, so if you take the mean value is how many point 1, 2, 3, 4, 4 points. So divided by 4. So x mean value is how much? 2.5. And y mean value is how much? 2.5. And then it this algorithm follows like this. First, it will, for each and every point, it try to calculate xi minus x bar. So 2.5 minus 1, like how much? Minus 1.5 minus 0.5, and then you have minus 0.5, and here you have 0.5. And similarly for xi minus xy. Okay. So we have 2.5 here, and this is the y value. So it's minus 0.5, minus 1 is minus 1.5, and then we have this of 0.5 and then 1.5. So after doing this, what we'll do is we'll do this formula: x minus x minus x bar into x y I minus y bar divided by x I minus x bar. So this gives you a certain slope equals to m. So for a given graph, this particular slope is called slope. This particular is something called as the tan value. So you will get this m value. So if you can remember in your high school days, you used to represent a graph something like this: y equal to mx plus b, or mx plus c. So where m is the slope and b is a intercept. So once you know this, what you do is for intercept, formula is simple: y bar minus nothing but this value 2.5 uh, uh, minus m value is whatever calculated value over here, and then x bar is the same value you get here. So once you get to slope and intercept, you can predict what is the next value. Let's say like m equal to say 2 and b equal to 3. So the equation forms like this: y equal to m 2x plus 3. So if you want to predict what will be the value for 5, what you will do is you substitute here. So 2 into 5 plus 3, which is comes as 13. So this is how best fit model works. And there are multiple algorithms how we'll try to define a particular equation uh, to predict the output. I will explain more about this, and I'll also explain step by step and matrix. I think here, this is the first step to understand about the equations and the graphs. If you have any questions, please let me know. I will go to the next concept. Now, I'm trying to explain the difference between prediction and classification. Now, for prediction, what we did, we try to identify a model and we try to predict the output. But for classification, you want to identify a particular class. For example, you have a machine, okay, and you give some input and you give some output. So what are the different classes in machine you can think of, on and off? So certain inputs, you want to classify outputs as on, and certain inputs you want to classify output as off. Let's say for AC you can say, let's say this is something you relate to humidity, and this is related to temperature. So at higher temperatures and lower humidity, you want to make it off, on. At lower humidity and more temperature, you make it off, something like that. Some kind of maybe my analogy is poor, but some class of inputs you want to make the machine off, and for class of inputs you want to machine on. So this is called classifications, mostly classifications problems. So what you want to do output. So there's the difference between prediction and classification is that in prediction you're trying to find you what is the value of output, but in classification you're trying to identify what is the class of it, whether you want machine to be on for these particular inputs or off for this particular inputs. So what you can do is certain inputs you can train a model, and then you try to identify the class. So by basing on the class, you give it as the output. So instead of giving a value, you give class as the output. So that is about classification and predictions. Now this makes a lot of difference. I will explain why this makes a lot of difference. So I mean, going back to a graph problem. So you have 2 dimensions. So normally when you have a problem in machine learning, you have multiple dimensions. But now here we focus on 2 dimensions. By focusing on 2 dimensions, we'll try to understand the concept, and later on we can take to multi dimensions. So right now in a board, I can draw 2 dimensions. So let's say about dimensions, 2 dimensions only. So you have X and you have Y. So you have multiple points here. Okay, so when you have a multiple points, so let's assume a particular model. A model is nothing but where you know a slope and the intercept. That's a model for 2 dimensions, let's assume. So when you have a point here, you see the distance of the point from here to here, a distance from point from here to here. What you're trying to do is you're bringing up a model which is reducing this sort of errors. So let's assume a point here. Let me take other color. Let's assume there's a few set of points here. Okay, and you draw something line like this. So if you have a predefined model, if you see this error and error from here to here, these two distance, this distance is less. So this means this error is less to this model compared to this model. So what you're trying to do is you're minimizing the error. Let me explain in some other algorithm. So let's assume you had given a problem to find the root of 9. What is the answer for root of 9 is 3. So instead of approaching like mathematical libraries, let's approach a totally different way. So what I do is for every square root of number will not be greater than half of that value. It means for 9, half value is 4.5. So the square root value cannot be greater than the half of value. So that is I'm sure about it. So what I will do is I will take half of the value as the solution itself. So my approach is, in my first step, I assume that 4.5 is the answer. So what I do is I try to see how much is the error. So I will calculate 4.5 into 4.5. It comes around to 24 point something. And but the expected value is 9. So 24 minus 9 is somewhere is coming around 15. So this answer is wrong. So what I will do is I will try to introduce some kind of learning rate. Let's say 0.1, say 10%. So what I will do is I will say in my next step, like the step number 2, this I apply this learning rate and I reduce this learning rate value from this value. So that is 4.5 minus learning rate of that value, which is nothing but 4.5. So it is 4.5 minus 0.45 is nothing but 4.05. So now I will test. So how I will test, I will square this value. 4.05 into 4.05 is coming around 20 point something. Of course, this giving me better value than earlier, but still this is not the perfect value for me. So what I do is I describe certain thing called epsilon. Epsilon, you can say it as a threshold value. I say that whatever error comes, if this is within this threshold value, it means I'll take that as an answer. In most of the machine learning, it's you have to deal with approximation. There is no closed form of solution. If you have a closed form of solution for all kind of problem, your problem is solved. But in real life, there's no there is very minimum such cases. So mostly in that case, you have to rely on these particular algorithms. So what I define is I define this threshold value that I can tolerate this particular threshold value. Until this, I will try to iterate these steps. So I'll go to in third step where I will reduce this one 4.05 minus 0.1 of 4.05. In the fifth step, I'll come up with the value of 2.98, which is in acceptable this threshold. If you are not happy with this, you can even increase this threshold value 0.01. So at that time, what happened? You will go with more number of iterations and you may end up in 65 iteration. You are coming with value of what 2.998, something like that. So here what we are trying to do here is we are trying to reduce the error, this error, so that we can reach to an approximate model to find the solution. Okay, I will give some time. If anybody have any questions, please ask. I think this is clear. This is much more for high school mathematics. Okay, so I'm assuming that this point is clear. I go to the next concept. No.
Till now, no question, Neeraj. You can go ahead.
Okay. I hope all participants are there. Okay. Okay. Now this is concept about the difference between prediction and classification. Okay. So for prediction, what we do, we have two dimensions. We have different points, and we have identify the model. And what we are trying to do is we have some initialization. Like we assume that this is a model, or this is the model. For each and every point, we calculate the error, and we try to find out which is the model that's giving the least error. So that is what we do in the prediction model. So in prediction model,
Neeraj,
yeah.
sorry to cut you there. We have one question. How do we arrive at the threshold value?
How do we arrive in threshold value? Okay, I'll just have to turn this one. I hope this board is working. Okay. Oh, did I remove it? Okay. Okay, so in the Python, I have that example in Python. I will show it again so you can see that. So in the first iteration step, what was our value? Value is 4.5. Second iteration we got 4.0. So what we trying to do is we calculate testing. So when we tested, it's coming around 24. It is coming around 20. So like that, we have went to further steps till to reach 2.98. When we reach 2.98, value is coming around something like 8.98 something. So if you separate 9 from 8.98, so you got 0.01, which is which where we have assumed that epsilon value. So epsilon value is something that you target. There is no hard and fast rule. So as long it works, you can have a different kind of epsilon values. So normally it depends what kind of problem you're dealing with. So if you are, let's assume you're dealing with money market, so like 100.58 makes sense, but 100.58999 in currency, does it make any sense? No, only 2 decimal point is enough, accuracy is enough. So that's how you decide during problem statement. So I hope I answered your question. How do we arrive? That's by ballparking. Why are we assuming? Of course, you can assume any learning rate. That's what I mentioned earlier. So in this scenario, I have assumed that learning rate is 0.1. So what for when I assumed it, so somewhere in fifth step only, I'm able to achieve. So sometimes it depends. There is some okay. That depends like how many iterations you want to do, how much computing capacity you have. Okay, I will tell you one example. Okay, before I answer any question, just give me some time. So what I have to explain is I have to explain about underfitting and overfitting. So let's assume that you are in some city, and like basing on the number of square feet, your price is increasing like this. But for every real life situation, the graph will not always be like this. Sometimes graph will go something like this. Okay, but if you have assumed that model is like this, so if you're trying to achieve model something like this, I mean, if you try to have some formulas like instead of y equal to mx plus b, if you try to have like y equal to ex, or like y equal to 20 power something, if you're able to try to achieve, so what happening is that you will try to overfit it. But once you overfit it, you never know, maybe due to some reasons, maybe because of some premium value, the actual value might have increased. So this is called overfitting solution, and there is underfitting solutions. This is underfitting solution. So you can never achieve whether 100% accuracy you can never achieve. So you may end up in overfitting and underfitting. So this epsilon, this learning rate is always ballpark. That depends like how far you are able to achieve your objective. So every machine learning, you need to come up with some objective and some kind of a threshold values, so that you can provide some certain set of rules. There is no such hard and fast rule. So learning rate, you can assume whatever you want. And somebody did raise your hand.
Yeah, it's Priyanka. Let me
Yeah,
unmute
please.
her. Yeah.
What is your question, Priya?
She's still on mute. Priyanka, can you unmute?
Sorry, that was by mistake. My bad.
Okay, no
Okay.
problem. So I
No
think
worries.
I have answered the question. Is there any more answer? Is there anything? Okay, fine. Then I'll go to next step. I hope this is clear. So if you go to any machine learning languages, so basic assumption is that you know matrices and all algebra, linear algebra things. So they start from the advanced level. So that is where you start spending money like me. So past 3 years, I spent a lot of money to learn all these things. So this is some kind of a Kickstarter for you. Okay. So coming back to the concept. Now this is concept is about what is the difference between prediction and classification. So y equal to mx plus b, actually how we represent in a mathematical world is something like this: ax equals to c, ax equal to b, and we'll try to either minimize or maximize the c of x. I'll try to explain this. So let's say you have an equation 2x plus y equals to 6 and 7x plus 8y equal to 28. So how do you represent in matrix world? We represent like this: 2, 1, 7, 8, like x, y, 6, 8. So like this we'll represent. So this matrix can be regarded as A, and this variable you can regard it as X, and this is represented as B. So there is a big reason why we do this, and this is really helpful. And this is the one reason why, in Python, because of all the libraries, matrix manipulation is very easy. So that's why in machine learning we use Python. Of course, in Java also we have good libraries, but Python syntax wise is very handy. Okay. Okay, coming back to prediction versus classification. So this is one reason why whenever you are given a problem, why you have to formulate a problem. So once you able to formulate a problem like this, your 80% solution is ready. So for prediction, if you see what we do in given points, we try to identify a model, okay, by reducing the error. But for classification, what you do is you try to increase this error. So this is on, this is off. So what you're trying to do is this imaginary model, whatever model you are having, you try to have those set of points in a model in such a way that the error is maximized. So for prediction, you will try to minimize the error. For classification, you try to maximize the error. In the end case, you anyhow you will achieve one or kind of a model, but you see the definition changes. So prediction, what you do is you try to make sure that you have a proper prediction, so that whenever you get certain value, you can have a proper output. For classification, you want to ensure that the graphs remain in such a way that when you get an input, you can classify the machine to turn on, or you can ask the machine to turn off. So that is the big difference between prediction and classification in terms of formulation. So in prediction, we will try to minimize the error, and classification, we try to maximize the error. Okay, I'll go to next step. I hope this point is clear. If you have any doubts, please ask me. Okay, fine. Let's go to the next topic. Next topic is about covariance.
Sorry, Neeraj, there is one question. What is a maximize error? What is maximize error?
Maximization. Okay. So if you remember what we did in Python, for a given value, we try to minimize this error. So whatever this error is there, we try to minimize it. But for classification, you want to achieve a particular model where you can have maximum of an error. Like the gap between the points for one particular class and the gap between the other particular class will be more. That's what I meant. So yeah, it looks more of same, but the intent is different. So when you actually start working on case-to-case problem, then that will be much clearer. So for now, for prediction, we are trying to minimize the error, and for classification, we'll maximization the error. So maximizing means we try to ensure to achieve a particular model where the error will be right. Okay, I can explain you better in this way. So let's say we have one point here. Okay, we have two lines. Okay, this is one line and this is other line. Which line has maximum error, which line has minimum error? So this line has minimum error, this line has a maximum error, right? So in our prediction problem, we want to ensure that we will achieve such kind of model, so which has the less error, minimalistic error. But in classification, we try to have such kind of a model where the error is maximum. So you might be saying there might be infinite number of solutions. Well, that might be a true case, but you see, for classification, you always have a two set of classes. One is for and one is opposing classes. So you try in classification, you try to achieve a particular model where the error is high, so that you can predict what kind of particular class if a new input comes. Whereas for prediction, you try to, you see, so now let's assume that this is the maximum error. What is the minimum error model for minimum error? This one. You see the angle changes. Even for minimalistic also, the angle makes a lot of difference over the long range of values. That's what I meant. Is this clear? If not, please ask me question. This is very important concept here. Good question you have asked me.
Yeah, Meeraj. Sender replied that it's clear.
Okay, it's good.
Thank you.
Okay, fine.
Yeah, everything good.
Okay, fine. Okay, now I'll try to explain what is covariance. So these things normally, if you go to any machine learning classes, they will not teach you all those things because they assume that you already know this concept. So they directly start right from the equations where it will go for bouncing. Okay, this took me a lot of time to understand these concepts. Okay, now multi-dimension. So let's say we have pressure, volume, temperature. Okay, so pressure is directly proportional to no, it's inversely proportional to volume. So we divide 1 by T, and then pressure is also inversely proportional to temperature. When pressure is increasing, volume is increasing. So I think it's directly proportional. Yeah. So that's what mean direct proportional. When
Meeraj,
yeah,
sorry to cut you there. I think there is some questions from the previous session. I
please.
can take it one by one.
Sure.
Does a slope show the degree of error or it is from the data points?
Okay.
Do you
Slope
want
is a
me to
model.
repeat the question?
Slope
Okay.
is a model. See, given any model, see here what now I'm maybe a few more things will be clear when I explain covariance. But for now, what I can explain, slope is nothing but a model. It's not the degree of error. So data points with respect to the training data points, you can say these are the points which you're trying to train. So this with respect to points, you're defining a particular model for 2-dimension. For multi-dimension also, we have something additional thing. Now can represent 2-dimension and 3-dimension. What about 4-dimension, 5th-dimension? Can we represent it? No, we can't. So what we do is we try to analyze certain things in 2 or 3 dimensions, and then we proceed further, and then we apply same to multiple dimensions. So is it a slope is a degree of error? Answer is no. And it's all depends on the data points. Please ask questions. You should be have more questions now.
Yeah. So moving on, next one is, do we mean distance between classes or error?
Do we need distance between classes?
Do we mean distance between classes or error?
See, classes is something you are actually virtually classifying. You are actually dealing with data points. So what we are doing is we are saying that, okay, this set of data points is particular class. This particular data points is a particular class. So the calculations, what you do is with respect to the data point. Am I clear? Can you please repeat the question again?
Do we mean distance between classes or error?
See, there is no such thing called distance between classes. This is all just virtual thing. There's no way you can calculate the distance between the class. You can only calculate distance between the data point to the model that you have imagined.
Yeah, I hope it's asked by Nitin. I hope it's answered the question.
If you have,
If you have
more
doubts,
doubts, please unmute his mic. We can have discussion. This is
yeah.
very important.
Please feel free to raise your hand, Nitin. And another one is, what if there are more number of classification instead of binary, like 10 classification, for example?
Yes, so there is something called k-mean algorithm and other things. So normally those are the real life examples. So you will see in those course material where you have something like this. Maybe like a fan speed 5, fan speed 4, fan speed 3. So let's say you have a fan, and basing on the what you say temperature or humidity, you want to set the value of the fan speed. So we know we have five triggers. So you can have something like this, 1 and 2, something like this. So See, this classification and all depends how you train your data. So let's say you have trained certain points. Let me color code it. So you train that certain data points, it should be within this class, or you train certain data points within this class, and you train certain data points within this class, and you train certain class within this class. So what will happen? You end up creating those classes with respect to the training only. So this is how you come up with multiple classes. So these two classes why I have taken is for explanation purpose. Yes, for multi classes also we'll do this. So again, it depends how many dimensions you are taking. Like we are right now, we are taking 2 dimension. They might be third dimension, like pressure and all those things. We'll come to that. Yes, we can have multiple classes also. I hope I answer your question. If any questions, please
Just
let me know.
repeating again, if you want to talk with Neeraj, please feel free to raise your hand.
Yeah, please raise
going
your
to,
hand. Yeah. So
Yeah,
these
going
things
to next
nobody will
question.
tell you. Yeah.
Sorry. Yeah, going to next question. What is learning rate? I think it asked a while ago.
Yeah, I already told learning rate is something that you assume. There are a lot of different ways where you come up with a learning rate that depends with the problem statement. There is no hard and fast rule that what kind of learning rate you set. That depends when you start analyzing, when you start working on it, then you will realize. Normally we keep some kind of thumb rule like 10% to 25%, but there's no hard and fast rule. Then again, that depends again underfitting and overfitting problem. If you see Andrew NG classes, you'll see something like this. So if you have a learning rate very small, let's say your learning rate is 0.0001. So then you'll go in steps like this. Then you will have more number of iteration, maybe 10,000 number of iterations. Then you have to reset because in order to save computation power, then you will reset as a learning rate as a 10%. Then with few number of iteration, you will achieve to the minimalistic error solution. But if your learning rate is extremely high, like 10, then you will end up like this. You'll come here and you'll come here and then you go there and you will never reach to this position. So there is no hard and fast rule like what kind of learning rate you set. And that depends on the solution you generate the model. See how you generate the model. See, you have given x1, x2 multiple and you have y. So you have certain y value, you have certain targets and you have certain inputs. So normally what we do is we divide it. Given a data, we'll divide it and we'll use this one for training purpose. After training, when we have a particular model, we'll test. So in testing only, you will find out what is the accuracy. Then you will know whether you're traveling, given this, whether you're traveling like this or whether you're traveling like this or whether you're traveling directly like this. So that depends on the stages that we'll see in upcoming classes. So for now, there is no hard and fast rule of a learning rate. Only thing is with the help of data itself, you'll try with the help of accuracy by training and testing, you will try to figure out what could be the learning rate value, and depends on your computation powers and all those things. Yeah, any more questions?
Yeah, one more is there from Ishu Gupta. How do we maximize or minimize the error? Is the integration concept used there?
How do we maximize, minimize error? There are techniques are there that we'll tell in future classes. Now we are focusing on concepts. How do you maximize error means simple. See, earlier example what we did for square root of value 9, we have predicted 4.5. Okay, now in order to minimize it, what we did, we have calculated what is coming around 24, but 24 minus 9 is something positive value, like 15. Okay, then you have reduced this further 4.05, like 3.5, finally you came up with the conclusion of 2.9. So you are able to, by reducing this error, we are able to identify the answer. Again, maximizing, again, it depends on that what kind of testing you are doing here. Here our test case is that whatever value you are predicting and the solution should be equal. This is the test case. So our objective is to minimize it. So what if instead of 4.5 by mistake it came to around 2.0. 2.0, it's 4. 4 minus 9 is equal to -5. So you know this negative. So if this is negative, then it means your direction is changed. It means you came like this instead of going like this. So here we are minimizing the error. How you are minimizing error? By testing. How you are able to test? By input data x1, x2, and y is output. You know all the values here. You know all the values here. By checking this value, you came to the conclusion whether you're maximizing the error and minimizing error. And how you're able to find it? Because given data, you are divided this data into two fields. One you are testing, one is a training. Okay, after training, you generated some model. And then you do testing, right? So when you do testing, you will know what is accurate. So testing, what you have testing values, and you already have y output values. So you make difference out of it. From here, you will find out what is accuracy. With that, you will identify. I hope I answered your question. Maximization error, minimization error, that depends on the problem statement and depends on the already received values here. So once you have, let's say you have model like 2x plus 3y. So you have something called 10. So you 10 and 20. So input 20 plus 30 is nothing but 50. So your test solution is 50. But as per your y output, it should be 55. What is the error? 5. 50 minus 5 minus 5. That's how you understand the error by testing and training model. Is that clear? Any questions?
No more questions.
Okay. Okay, now I have to explain very important concept about covariance matrix. Now about the dimensions itself. Now, there might be, this algebra is so confusing. That is why reason why many people try to misunderstand machine learning. So let me make it clear. When I say 2x plus y equal to 6. So x and y are inputs and 6 is the output. And x is a variable, y is a variable. But when you enter into machine learning, they will represent it like this: 2x1 plus x2 equal to 6y, where y equals to 1. This is how we represent x. For x, our prefixes are input and y prefix for output. So this is one reason why there will be a lot of confusion. So you have to be clear what you are representing. Okay. Now we are going into the multi-dimension. So far we are looking into 2 dimensions. Now we go for the multi-dimensions. So what we did earlier, so we have a square feet. And then what is the thing? Cost. Okay, so for 100 square feet apartment costed 1 lakh. For 200 square feet costed 20 lakhs. This is L. So like that you have input. So what is this? This is x1. This is x2. Okay, so what we are doing is that basing on this, we have predicted some output. But sometimes it's not only on square feet, it also depends on number of bedrooms. So like 1 bedroom, or maybe this is for 1 bedroom. Maybe if it's 2 bedroom, maybe for 200 square feet, price might be 2.5 lakhs. Okay, this is second dimension. Okay, and what is this second with balcony? So if balcony, let's hope that these are all having 0 balconies. This is okay. Even this one has a 0 balconies. But same apartment, which is 200 square feet, which has 2 bedrooms, has 1 balcony, say cost 3 lakhs. So how many dimensions we have? 1, 2, 3, 4 dimensions. Okay. And what is next? Maybe like near to school. So these are all not near to school. So the same 200 square feet apartment, which is having 2 bedrooms, 1 balcony, and near to school, representing as 1, is 3.5 lakhs. So what happening is that you are keep on adding the dimensions here. When you keep on adding dimensions, so sometimes what you need to do is you need to come up with a covariance matrix. So covariant matrix is something where you need to understand what is the relationship between the multiple inputs. Okay. To explain that, I will explain in a bit further. Okay. So we have pressure, volume, temperature. So when pressure increases, volume increases. So they are proportional. When pressure increases, temperature also increases. Okay. Don't go into physics, just let's assume that this is correct. And volume, so when there is a more temperature, volume will be more, right? No, it's pressure, volume. When you more temperature, it will be more temperature. So when you have more temperature, volume, let's say volume is less. So volume increases. When temperature increases, volume decreases. So I can say inversely proportional. So pressure is directly proportional to volume, pressure is directly proportional to temperature, but temperature is inversely proportional to volume. This is like in physics, you are able to understand by making some observation and making something as constant. P is proportional to V when temperature is constant. P is proportional to T when volume is constant, and T is inversely proportional to volume when the pressure is constant. By doing certain set of experiments, you are able to identify this. But given a set of data, like like square feet, like a number of bedrooms, and whether balcony is there or whether it's near to school, when you have multiple dimensions, how do you identify the relationship between each dimension when you without performing experiments or with looking of the data? For this we use covariance matrix. There is a formula for covariance matrix. So what you have is earlier I have mentioned this matrix like something like 2 1 7 8 x and y and 6 and 28. So what you have 2 dimensions here. So you have like multiple dimensions like 2 3 like 100 dimensions and 16 dimension 4 6 something. So here you have input is x1 and x2, output is y. So here input is x1 and x2, and let's say xn or x16. So but here maybe not all dimensions may not affect. There is a chance that in the given data, even if the school is near, the cost is only 3.0. So this dimension may not be applicable to analyze. So how do you identify the relationship with different dimension is using covariance matrix. There is certain formula with it. I will show it. I'll show in the demo part. So what will happen is, so whenever you have something 3 input or n input matrices, you come up with certain matrix, and something it will come up something like this, like 10 0. So when you calculate covariance matrix, what we'll do is we will ignore the diagonal matrix because it is relevant to the same matrix. So like it's like this x1 x2 x3 x1 x2 x3. So each block represent the relationship between the other variable. So here x1 relationship between this 1 comma 1 represent means the relationship between x1 and x1. X2 means the relationship x2 with itself and x3 with itself. So this diagonal will ignore it. When you see this one x1 and x2 here, the 4, so this is positive value. Positive value means it's proportional. Here also it will be almost same. So it means x1, the relationship between x1 and x2 is directly proportional, just like p is directly proportional to v. Okay, and then if you see x1 and x3, it's a negative value. So it means inversely proportional, something like P is inversely proportional to temperature, something like that. So with the help of covariance matrix, we will identify the relationship with each and every variable. So if there is a multiple dimensions also, you can identify, if let's say if it is minus 10, then this is x4. So it means x1 is inversely proportional to x4, and it's in large quantity. It may be like if this x1 is somewhere 1, then x2 will be 10 times of inversely proportional, maybe like 1 by 10.1, something like that. So covariance matrix is one of the important concept to understand. I think this is clear. Shall I go to next concept? Any doubts here? Okay.
No question as of now.
Oh,
You
okay.
can go ahead.
Now we go to next is eigenvalues and eigenvectors. So eigenvalues and eigenvectors are very important concepts. This is widely used, but I try to explain whatever I can. So let's say you have mostly it's all related to matrices and vectors. So most you might have remember when we are using geometry class. So given a plane, what is the vector? So let's say I have this plane. If you assume this is the plane, okay, you see this plane. I want to know what is the vector. So this is the vector. So if the plane is like this is the vector. If plane is like this is the vector. So vector normally it represents certain data points or certain what we say dimension. So mostly everything is done in terms of vectors. So if you have some kind of data inputs to something 2, 3 or 4 something, what we do is we need to identify the vectors. So vectors is a different concept. Just like I have explained how we are representing a plane as a vector. So so let's say for a given set of data, so you have some vector like this. It means it's more like a representation of particular dimension. This is one vector v1. This is not a model, this is a vector. Please note that point. This is a vector, not a model. So we have v1 and v2 like this. So what we'll try to do is we try to identify eigenvalues and eigenvectors in such a way that it doesn't change. I mean, you can identify the transformation, or you can identify the skewed version of it. Okay, what is transformation and skewed means? That also I'll explain. So let's say you have a given set of plane and you have a vector like this. So we identify vector like this 2, 0, 1. If you can remember high school mathematics. Okay, the current is gone. Let me see if I can connect something else for light. Hope you can see. Okay, nice. So you have a particular data points we are representing as a vector. Vector is a different concept. It's high school mathematics. Please go and check it out. I'll not go into that details. So you have this particular vector. These vectors are nothing but data points, but they are the representation of a dimension. Like for example, let me explain. If something like this 4, 2, 1, and this is like 8. Let's say 4, 3, 1, 8, 6, 2. And then 12, 9, 3. So here is for this particular data, you can say the vector is something like 4, 3, 1. Why 4, 3, 1? Because every dimension can be represented with this vector by its respective value. So let's say if I multiply by 1, I can able to represent this first dimension. Okay, if I multiply this vector with 2, I can represent this particular dimension. If I multiply with 3, I can represent this dimension. So it's about matrices and dimensions. So with given one vector, you're able to define a particular data set. So that is vector. Okay, any questions in this? Okay, that comes under matrices and vectors. So these things something important when you start formulating things. Okay, now what I'm trying to explain, what is transformation? So transformation is that I extend the value by 2 times. So this is v1 and this is v2. So what is happening? This is 2 times of v1. This is 2 types of v2, which is represented as v1 dash and v2 dash. This is transformation. And then skewed. Skewed, what we do is we try to change the angle. Maybe I'm not able to draw here. Maybe. Okay, current is gone again. There's a. Hope you see this. Okay, it came back again. Okay. We change a little bit angle like this. This is v1 with same quantity. This is v2, same quantity. So here, what you're doing is these two things, you are just transforming or you're doing skewing. So these two are vectors like this. Here, what you do, you have extended it, transformation. Here, what you did, you just turn the angle like this. This is skewed. So when you have such kind of data, what you can do is you can find the eigenvectors and eigenvalues. So when you're able to find for a given set of vectors, if you're able to find eigenvector and eigenvalues, so what it gives you the flexibility to transformation or skewed, even if given data is transform or skewed at given it to you. With the help of eigenvectors, you can rearrange them in such a way that you can have proper input values. To how to explain that? Let's say we all know that what is a force equals to mass into acceleration. Okay, you have a force of a car. Okay, so the car acceleration is in terms of 10 per second, 10 meters per second or something like that. And if you take, for example, a rocket is like maybe 10,000 meters per second or something. See, both are almost in a same relation, but values are skewed. Okay, here with the help of physics, you're able to identify the equation. So this is more like a closed form. But in given set of data where you don't know the relationship, how you will stress that these two quantities almost in a similar with the help of eigenvalues and eigenvectors. So there are certain videos within eigenvalues and eigenvectors which I'll share it. Please see later on. It's a very good tutorial to understand why we need eigenvalues and why we need eigenvectors and how to use them. This is very important concept to learn, because when we start doing SVD and algorithms and all those algorithms, you need to know what is eigenvalues and eigenvectors. So today I don't much cover on SVD, but let's see, I want to, basic on the feedback, I want to see how can I proceed further. So okay, this is about eigenvalues and eigenvectors. Any questions right now, please ask.
No question needed.
Okay. Okay, and there is something called single value decomposition. So I will explain what is it. So SVD is very powerful and widely used in all many machine learning. So that's why I thought let's explain that particular stuff here. Okay, this is totally tight here. In this I can loosen up. Yeah. Okay. So there is something called in Netflix, you called movie suggestion. So you will be surprised, right, how Netflix come to know about my taste. So what we'll do is this is nothing but there will be a dimensions. Let's say you have a movie. So there is something called genre. What kind of genre, like action or comedy or something, and ratings. So you like 5, 4.0, 4.5. So like this, you have a lot of data. So what will happen? You end up with something extremely large data, like 1, 0, 10, 20 or something. So you have a large set of data. But in this one, only few set of data will be rightly representing the user preference. Let's say there is a dimension. Let's say you placed all the rows in terms of user ID 1, user ID 2, user ID 3 and 4. There will be a small set of matrix which actually representing the entire set of data, just like eigenvectors and eigenvectors and other things which I have explained here earlier here, just like this. So you have one vector which is representing the other dimensions. So in similar way, so you have this particular preferences and basing on dimensions. So this is maybe some kind of rating, maybe this is genre, maybe this is language or something. So there is a set of matrix where it will give you the preferences. So what we'll do is there is something called SVD, single value decomposition, which will be a matrix, a given matrix will be separated in terms of 3 matrices. For decomposition, it's a very big terminology. So when you take a particular vector, you will know it will preferences. So when you try to give some input for this particular vector, we can identify which is your preferences, and basing on that, we can give that output. So that's for single value decomposition. This is a very large thing. The definition is something like this: like SVD is a factorized of a real and complex matrix. It generalizes the eigen decomposition of square normal matrix with orthonormal eigenbasis to any matrix. Okay, this is very complicated one. So it's a complicated definition, but you see, try to understand this here. When you see eigenvalues and eigenvectors, these two vectors are same. Here is just extended, here is skewed, but you have a real matrix that actually have the representation. So that representation you can discover in SVD. That I will take up in future classes, but it's good to know what is SVD. So if you can do certain research on SVD, it will be very helpful. It is used in wide application. So one is, I have told you that Netflix movie suggestion and other things. And most of the suggestion, wherever you find any suggestion like Amazon and all those things, they follow this particular thing. So you need to know matrices. That's what you need to know. So 611, do we need a break? There are many concepts are there. I have to show demo also.
I think we can skip it for the time concern.
Okay, sure. Oh, I think I have to speed it up then. Okay. Loss function I have explained. Gradient descent. Okay, gradient descent is a very simple thing. I think I don't have to explain, but still. So if you see, remember, for square root of 9, we took 4.5 and then 4.05. So what we are doing is we are doing gradient descent. So what you have, we are measuring, you're measuring certain error here. Okay, there is some error here. The error is 24, error is 20, 16. And finally here you come 0.01, which is epsilon. Okay, but if you iterate more, again, the error will keeps on increases in different direction. Like, you know, for example, 2, it was -5. For 1, it will be -8. It keeps on increasing. So what we are doing is we are trying to train and we're trying to identify least error. So this is concept of gradient descent. This is something called gradient descent, and then we have gradient descent. There's a big definition. I think we don't have to focus on this. Okay. Next concept we'll go. Okay, NP problem. So given a problem, you have a closed solutions, but there are certain solutions which the solution doesn't exist. So what you'll do about it for hard problems? For example, let's say you have a case like you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have two players, player 1 and player 2. So you have to pick up 3 numbers in such a fashion that the value should come as 15. And each player will choose 1 at a time. If I choose 2, there is a chance the player 1 choose 4. Then I have to change the strategy. So this is the harder problem. So what you can do is you come up with another problem where you can come something like this: 2, 4, 9, and then 3. Okay, 2, 4, 9, and then this is 3, 5. 2, 5, 7, 7, and then 8. 8, 4, 12, 12, and then 3 here, and 3 and 9. This is like Sudoku. So okay. Okay, so actually you come up with some kind of Sudoku where you can have each and every row as a 15 as a summation as 15. This is not a perfect one. There is one video which I'll share it. So what you do is you have another problem where you can have 3 particular columns where you have a 15. So this solution can be applied to this particular problem. Only thing is it is structured in different way. So there's a debate is going on that P is not equal to NP and P equal to NP. That's bigger things. If P is NP, I mean, thing is that for every problem there is a solution exist, then everybody becomes scientists. Some kind of debate is there that I will share you the link to show. So right now in machine learning, what we are dealing is with the NP problems. So NP problems, what we do is we try to come up with a solution for a particular problem that is related to NP. That I will share that link with which gives the detailed information. Okay, till now we are going with 2 dimensions, and now we are going with the multiple dimensions. So earlier we had did this 2x1 plus x2 equals to 6 y1, where y1 equals to 1. So in linear equations, linear equations can be represented like this, c1x1 plus c2x2 plus c3x3 is equals to y. This is a linear function. Another thing is non-linear function. If you represent this is f of x, and this is if it has some value equal to 6, this is for linear equality. Now we have something called non-linear equality. So non-linear equality is where f of x is less than or equal to 6, or f2 of x is less than equal to 28. So for example, let me take this here. So you have this problem, 2x1 plus x2 is less than equal to 6, and 7x1 plus 8x2 is less than equal to 28. So what you can do is you can represent this with a matrix 2, 1, 7, 8, xy, 6, 28. So what you do is this is nothing but ax plus ax of c. So, or you can say x equal to c dot value of a of inverse. There's some formula for this. So what you can do is you have to find out the formula for a solution for a inverse. So if you give an input a as this, you can calculate what is a inverse. So a inverse something like this, 0.8 minus 0.7, 0.6, 0.5, something like this. So when you multiply this c, that is 628, with this particular matrix 0.8 and minus 0.7, 0.6 and 0.5, what will happen is you will find the xn value, the intersection points, which is nothing but 2.2 to 1.55 x value. So what we did is, with the help of matrices, we're able to solve a given problem. Now in linear programming, what will happen is we have to mostly deal with inequalities such as, so now you know that using matrices we are able to identify what is the intersection point. So let's say you have this point like this. This is 2x plus x2 equals to 6, and other one is something like this, 7x plus 8x2 equals to 28. Now if you see the problem statement here, for this inequality, this values lies within this boundary, and these values lies within this boundary. Okay, now the optimum solution is 2.22 comma 1.55. Okay, this is for normal scenario. But what if okay, this is true if you have something like pressure, volume or something. What if it's integer value, like number of foundations versus number of pillars? So this cannot be this float values, it should be integers. So you will have 2 points here. when you have 2 points here, how do you identify which is the solution? Then you need to check for the problem statement. So problem statement is something like this, 3x1 plus 2x2, and you have two solutions here, 1 comma 2, and this is 2 comma 3. So you plug in 1 comma 2 here, 3 plus 2 equals to 5, and this one 6 plus 6 equals to 12. So this is having maximum value. So this is the optimum solutions for this. So this what we did is right now is linear programming. I think I have went too much into theory. I will show certain demo points. Is there any questions till now? This is the next set of concepts. I think I will cover in some other day. Anybody have any questions so far? I will before I go to demo. Okay. Okay, let's go for a demo then. Oh, somebody asked some question I did not see. Okay, can intersection be achieved by Cramer rule? I don't know what is Cramer's rule. Very good question. I should check. So actually, and what I'm here is I'm trying to explain linear programming at the basic level. Maybe in future I'll see. A straight line intersection. I don't know what is Cramer's rule. Okay, so we'll go with demo. I'll stop this one. Okay. So it was a big theory session. Okay, let me share my screen. So there are certain things which I have to share before you people go. So certain video links and all those things. So people who wants to start with the machine learning. So this is how you have to start by learning these concepts. So all this concept I have explained you on the board, like basis of machine learning, expectations, and all those things. So what I did is I created my own tool here. This is in Java. I hopefully share this to everyone. So this is actually basically a tool which I have applied the same concept in Java. It's not in Python because most of the people in Java are in Java, so they get used to it. So they'll have some sort of hands-on, like how you can actually implement machine learning concepts. So if you see here, I have used the concept of best fit algorithm. So let's say I have some x value 10 comma 10 10. Okay, so here is the point. So I will do again 20. Okay, and then I have something called 30 and 30. Okay, so what I have given, I have given this application 3 data points. So what I will do is I click on generate. See, if I click on generate, it is able to identify the model by itself. How? With the help of this same calculation which I explained in the board. You can see this x mean value, y mean value. I have calculated x1 minus x for each and everything, and then x1 x square, and then I identify slope and intercept. Now if I want to predict something, so I want to know what is the value of 40, it should be 40 actually. So I click on it, so it's saying the expected value is 40. So this is I just gave it as a dummy value, but it is this value came out of this model calculations. So this is how you can come up with with the machine learning algorithm into your app. Best fit is just one of the statistic model, but there are several other things. Just to explain you in a bit, so I was going there. Okay, there are some chat. We can see the PPT. Okay, you're not able to see this one, the demo. Anybody can see?
Yeah, Miraj, I guess it's not visual.
Oh, application got freeze. Okay, let me run again.
We can see the PPT only, not the application.
Okay, I'll stop sharing and again start sharing. Okay,
Yes.
can people see the app now? Are people able to see app? No?
Yes.
Yes.
Okay, okay. So this GitHub link I will share. It is open for the public. So that's what I'm saying. If you give certain values like this, okay, so there's a dot here. So I will have other one. So there's another dot. So I'll click on generate. You see model is generated here. So you can see all the calculations made over here. So once we able to find the model, now you can test it out. So let's see what should be the value of 30. I'm expecting that it should be 30. So let's see what it predicts. See, it predicted the value 30 basing on the slope and intercept values. That's what I was trying to say. So this is, I mean, you can have multiple algorithms. Just I'm trying to showcase how you can implement a particular use case. So once you know the concept, it's easy to implement. So all those logic, you can find it within the code. So I placed it there like using best fit algorithm. Again, for class generation also, let me show you the class generation. Okay.
Miraj, before going that, I guess one item is has one raised hand.
Mhm.
Allow him to talk.
Yeah. Yes, please tell me the question. Hello.
It is he's in mute. Okay, you can continue now. Please.
Okay, so I'm trying to give certain inputs like random values, class A. So class A is represented as red dots. Let me go in reverse map 40, 10. So this is class B. You see this class B is represented as native dots. So I'm trying to generate here. It's coming up like this. It's supposed to come like this. Why it is coming like this? Because I've used this best fit algorithm. So best fit algorithm is more like minimization, but minimization doesn't work with the classification, right? So the line should have been come like this in the perpendicular of this particular line. So that is the reason why you need to formulate the problem before you enter it, whether it's a classification, is the prediction, whether it's the minimizing the error or maximizing the error, and what should be the learning rate and all those things. So this is about a tool which I have written myself by after understanding machine learning algorithm. So you can also do it, and hope if you can contribute also. Okay, and then certain examples I want to show in Notepad. I will share that YouTube links and this particular links. Uh, okay, where is that YouTube? Yeah, here is the YouTube links which explain about NP and NP problem, which I've tried to explain. And I also have in the YouTube link there, you can see the GitHub links where you can find these examples here. So here you're seeing the covariance matrix here. So I was explaining different values. How do you identify the dependencies of each and every dimension to other dimensions? So with respect to heat map, you see it's a negative value here. Negative value means inversely proportional. Positive value means it's proportional. There are a lot of examples written here, and some of them I also given examples. How do you calculate a mean column wise, row wise, and with the help of using NumPy, how you can do. And graphs are very important. So if you are starting with Jupyter notebook, see you can how to work with graphs also. So all those graphs examples are given in that video. So loss functions and many examples I have mentioned, and let me show some examples about gradient descents. So gradient descents also you can see. So here what you're having, you have multiple data points. You're trying to predict a model like this. You see, I'm using a library, OLS method of a library. Which library? Stat models. And there is a other library called ski learning. So no matter which language you use, no matter which library you use, internally they're following the same concepts. So if you understand the concepts, that's more than enough. You can play with the subject, whichever way you like. I think there are a few more things which I supposed to share, because for the time constraint, I will stop it now. So Flox, forum is open to you. I think a few more things I will share in future sessions if time permits, yeah, basing on the feedback. Yeah. guys.
Would you like to share the links on the chat, please, sir?
Sorry, yeah, links. Okay, let me share those links. Meanwhile, if you can conclude, please go ahead. Yeah, I'll share it in the chats. Yeah.
Sure. Thanks, Neeraj. Thank you for the wonderful session. It was really interesting and interactive. Thank you so much. And thanks, everyone. So before we drop off, as I told already, please feel free to fill the survey. I will be sending that in the chat. Yeah. You might have got a chat message. Please feel free to fill the survey so that we can see what we can improve and all. Yeah, I hope you enjoyed. Meeraj, is it done sending the links and all?
One GitHub link I'm trying to search. I forgot regarding the tool.
Okay.
I'm trying to search. Just give me a minute.
Meanwhile, there is
Yeah,
also
yeah,
a
sure.
question on the
Yeah.
Q&A.
Yeah. So the question is, can you suggest some basic projects once we have the basics of ML for hands-on?
Yeah, so basics, what you have to do is you have to learn linear algebra and then matrices. And then something like which I have mentioned today, topics like eigenvectors and all those things. Eigenvector is very difficult concept and SVD. First you learn matrices and linear algebra. I will share those YouTube. At present, I don't have links. I'm sorry, please ping me. I can guide you later. Yeah, after that there are certain courses which I will show it to you. Yeah, so one thing what advice I can give you is if you go to any course there are any kind of things, unless you know all these concepts, you don't understand those things because they are going little bit advanced, and it took me very hard time to know about it. So if you are a new person and if you are enthusiastic to learn, try to reach me out. I try to explain and how to go about it. Yeah.
Okay. Thanks, Meeraj. I think we are running out of time. If we have nothing, then we can stop it. So, as I already told, please feel free to fill the survey. Thank you so much, Meeraj, for the wonderful section. Thank you, everyone, for your time and your support. See you again. Bye.
Thank you, everyone. Bye. Yeah.